Hello friends, today we will see one question which came in GATE 2006 and it is based on relaxation oscillator, and then we will see how to solve this question. So in the figure you can see op amp is there and its saturation voltages are plus 12 volt and minus 12 volt, and we have to find the waveform at point P. So the question is find the waveform at point P. So we have to find the waveform at point P. So as this is an oscillator, it is working in positive feedback. So let's start and see how to solve this question. Okay, so answer. Step 1, assume this is VO, assume VO to be plus 12 volts. As this is an oscillator, so output voltage will be either plus Vsat or minus Vsat. So initially I am assuming it to be plus Vsat, that is plus 12 volt. So VO is 12 volt. Let's mark this point as A. If VO is plus 12 volt, so this diode will become off because the negative of diode is having a higher potential. So this diode is off, while this diode becomes on because 12 volt is directly connected to positive side of diode. So this diode is on, this diode is off. Similarly on this side, this is plus 12 volt and this is plus 12 volt. So this is off and this is on. So let's make the diagram again while considering output voltage to be equal to plus 12 volt. So diagram will become like this. This is 10 kilo ohm and this diode will be on, so this will be 10 kilo ohm and this was plus 12 volt. Now current here is 0, current going here is 0, so this 12 volt will divide equally, or you can apply voltage division rule. So 12 volt at point A, VA will be equal to, by using voltage division rule, 12 volt into 10 kilo ohm divided by 10 kilo ohm plus 10 kilo ohm. This 12 volt will divide equally between these two resistance, so it will become 6 volt. Now see, this potential become 6 volt and initially capacitor was charged as 0, so initial voltage of capacitor is 0 volts. Now when this voltage is at 6 volt, so positive is more than negative, so this will remain in 12 volt. There is a path for a capacitor to get charge, so a current will flow like this. Here current is 0, but a current will flow like this and capacitor will get charge. Now capacitor will get charge and it will get charge, it will start charging from 0 to certain voltage. Now this is point P. Up to what point P will get charge? So current is flowing like this, so polarity will be like this. So see, if voltage at point P exceeds the voltage at point A, then my op amp will the output of op amp will switch. So when Vp exceeds Va, then Vo switches. So this was the diagram, right? So if VP exceeds VA, so the output switches. So let's start drawing VP first. See, this is VP and this is time. Now see, the current is flowing like this. This is plus 12, minus 12. Now the current is flowing through R and C. Current here is 0. So when your current flows through a RC circuit, this is like a RC circuit, right? Here is your 12 volt voltage source and current is coming out of 12 volt source and it is flowing through R1 and C. So it is like a RC circuit. So for any RC circuit, the capacitor charges exponentially. So capacitor, initially it was at 0 volt, it will start charging. So this is it will charge up to a certain point and this will become, it will charge up to 6 volt. Why? Because as soon as it crosses 6 volt, the output voltage switches and output switches to minus Vsat. Why? Because negative terminal exceeds positive terminal. So let's mark this point as T1 and let's see what happens after T1. So after T1, VP exceeds 6 volts, so output switches. So VO switches to minus 12 volt. Now VO switches to minus 12 volt. So how does a diagram become? Let's see the question and then let's analyze. See, if this becomes minus 12 volt and if this becomes minus 12 volt, the negative side is connected to most negative, so this diode will be on. Similarly, this diode will be on, while negative voltage is connected to the positive side of diode, so this will be off and this will be off. This diode and this diode will be on. So the diagram changes like this. So after T1, VO switches to minus 12 volt and the diagram changes like this. This is capacitor. This will be R2. This will be minus 12 volt. This will be 2 kilo ohms. And this will be 10 kilo. This is VA. Now, so VA will, let's find VA. This minus 12 volt will divide between 2 kilo ohm and 10 kilo ohm. So using a voltage division rule, VA will be equal to minus 12 volt into 10 kilo ohm divided by 10 kilo ohm plus 2 kilo ohm. So this will become minus 10 volt. Now this potential became minus 10 volt and this after T1, this capacitor will get charged up to 6 volt. So this VP is 6 volt and this potential is minus 12 volt. Now this is at higher potential and this is at lower potential. So current will start flowing like this in this direction. So once the current is flowing in outside of the capacitor, means current is flowing in the direction opposite to the current earlier it was flowing. So if the current is flowing like this, this capacitor will get discharged, right? So now this capacitor, this VP will get discharged. VP is the voltage across the capacitor, right? So this will get discharged. Now we have to find up to what point this VP will decrease. Now see, this potential is at minus 10 volts and this potential is continuously decreasing from 6 volt and it is decreasing exponentially. Now this potential will VO will again switch when my positive terminal is more than negative terminal. VO will switch when VA becomes greater than Vp, right? If positive terminal if positive terminal becomes greater than negative terminal, VO switches. So this Vp will decrease, and it will decrease up to minus 10 volt. If it becomes minus 11 volt, obviously this potential will be higher, so VO will be plus 12 volt. VO will switch from minus 12 volt to plus 12 volt. Again, if you take this Vp, if it is decreasing till minus 10, this is minus 10. As soon as this potential goes little bit more negative than minus 10 volt, VO switches, and then this potential will be minus 10 volt and this potential will become 12 volt. Again current will start moving like this, and capacitor will again charge. Again it will charge to 6 volt. So this was the working of this circuit. Basically Vp first charges to 6 volt, and then again this discharges to minus 10 volt, and then again it charges to 6 volt, again it discharges to minus 10 volt. So your final voltage Vp will look like this. Initially it was 0, it charges to 6 volt, VO switches, it discharges again to minus 10 volt, again as soon as it goes more below than minus 10 volt, VO again switches, then again it gets charged to 6 volt, and again it discharges. So this is the waveform at point P. So this is the correct answer.